Action.
Okay, so the idea is we're going to make a polyamide, which is going to be nylon. But we would, as I said, use a dicarboxylic acid, which we're not going to do. We're going to use an acid chloride. So if you look at the molecule on the board, rather than having OH groups coming off of it, you've got chlorines coming off of it instead. And we'll think about how that affects it as we do the practical. Okay, pause for a minute.
Go.
Okay, so we need, first of all, to get an organic solvent. This is petroleum ether, and this we're going to use to dissolve the dichloride. So it would be the acid that's got the chlorines come out. So I'm going to take 15 centimetres cubed of this, and into it I'm going to add about 0.5 centimetres cubed of this stuff here. But this is the nasty stuff. I'm not going to be gloves again.
Oh well.
Never mind. Okay, so I need a pen. So I don't need a huge amount, but about 0.5 of this. So let's go. And that dissolves quite nicely in that. Right, the other thing I need is I need the diamine there. So the diamine, if I whiz it out, you may be able to have a look. What we're going to have is we're going to have about, I think, it's about 0.7 grams of this stuff. So let's put that in.
Yes.
Right, so that can go in there. And into it, I'm going to add 15 centimetres cubed of water. This one I'm going to dissolve water. Why would this dissolve in water, do you reckon?
Because ionic.
It's not, it's a diamine. So what's it got in it?
Hydrogen bonds.
It can make hydrogen bonds.
But I also need to add into this about 2 grams of sodium carbonate. Why do you reckon I need to add this?
Neutralize it?
What product am I going to make? If it was a diacid and a diamine, what would be my byproduct of polymerization? It makes an amide, and what's the molecule that's eliminated?
Water.
Water. What's it going to be now if that OH has been replaced by a Cl?
HCl.
HCl, yeah. What will HCl do to a diamine?
Destroy it.
And add a Cl onto it, won't it?
What does an amine act as? An amine acts as a base. HCl is a
Acid.
So I would form the salt. And if I form the salt, it's not going to want to react at all. So this will mop up any HCl that is produced, and it just has to react, but that needs to dissolve up a little bit. So while it's dissolving, do you want to just pause it? That's pretty much dissolved. I've still got a little bit going on, but it's not too bad. So what I'm going to try and do now is, rather than just mix it up, and I'll show you what happens if I just mix it up later, I'm going to try and layer that on top of the water. This is an organic solvent, so this is petroleum ether. This is water, so they shouldn't mix very easily together. So one should sit on top of the other. So let's give it a go. So I'm just going to run it down the side, and you should hopefully see
What layer?
2 layers appearing. Right, the first side, you need to kind of do this a little bit slowly at the beginning, and once you've got the 2 layers established, you can be a little bit more. Right, so hopefully you can see I've got 2. Does that come through okay? I've got 2 layers. So, at the interface of those 2 layers, I am forming nylon. So that's where my 2 reactants are mixing. Right, cheers.
And then
Right. So I've got to get that nylon out. I have got
Tweezers.
a rod, and I've got some tweezers. So let's try.
It's like a spider web, isn't it?
A little bit, yeah. So hopefully it's formed the nylon. So, and what I can do is I can run it. Why is it quite good to do it this way? rather than just mix it all up.
Like a thread can be used for clothing.
Yeah, absolutely. That's how we want it. We want it to be a nice thread, don't we? Now, it's a tube. In the middle of the tube are the reactants that haven't fully reacted together. So you wouldn't want to. You'd have to wash this quite a few times. But it's quite that's coming out nicely, isn't it?
There's
You
so
can go
much.
quite fast.
Can I feel it?
No.
Why?
It's like a cocoon. It
Yeah.
looks like
Yeah,
it's
that's what I
like
thought.
a wool.
A little bit, yeah. It's coming out quite nicely, but you can see how smooth it's coming out. Right
How
in the
much is
middle.
there going to be?
It looks like a cocoon.
Oh, I could go on for ages. It's quite because there's not actually that much.
Will it unravel again? Does it stick to it so?
Sorry?
Will it unravel again? You know.
No, back.
Sorry.
Now I've got a lump going on.
Oh, gross.
Oh.
Could have just said yes.
Now, what you would want to do, if I allowed you to do this, and because I'm a miserable git, I'm not, is you would want to pop this. And then you squirt reactant all over your face. Start crying. So, yeah, you can't be trusted basically. But you can you see how it's dripping down? Where it's winding itself in on it, on its own. But that is quite a nice lump of nylon. So I will now...
When you say you could go on forever, how
Well,
much is in the pot?
Until the accents run out.
I could go on for quite a long time.
It has
Go
gone down a lot in
Yeah,
the queue.
yeah.
So you're using up the liquid?
Sorry?
Yeah.
Well, it's a little bit. I mean, you can see the liquids.
No, keep going.
Is anything else produced?
Only HCl. HCl's being reduced.
Keep going.
Well, I won't go in there. So if I cut it off, and then I will pop it in here, and then you can have a...
Come over here and show the camera. Oh, it looks like a cocoon.
Yeah, oh yeah, it is actually. It is very much like a cocoon. So there you go.
Oh, it looks like gnocchi.
Like what?
Gnocchi.
Oh, okay, like the potato stuff. Yeah. Oh, okay, yeah, cool. And there you go. That's nylon. Right.
Michael.